Hey everyone, have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Hi everyone, so the last time we were able to actually decrypt the message, which was actually a lot easier. Now that we knew how to encrypt the message, we had all of the pipes already there from all the functions we had made. So in this video, we're just going to talk a little bit about some of the limitations of this and actually cracking this cipher, which is surprisingly easy. So first thing we're going to do actually is, there's a little bit of a mistake in the last video. We're going to replace in these two functions. Right now, they're just passing in a particular number for that right shift value, which is kind of important to the cipher. We're going to actually change that. So I'm going to say right shift is equal to 23, which is the default right shift value, and then replace that 5 with right shift, which is the same thing we've been doing for the other functions, but we didn't do it here, which, was fine for our purposes for what we were doing. But right now, I think it's better to have that. So it's a little bit more generalized. So I could put in any message in here. I could put in any number that I want. So let's say I use 15, and then I can decrypt that message. See, that wouldn't work, but if I use 15, it would decrypt the message with the same shift. So that's the first thing I wanted to do. But the second thing I wanted to do is just ask, how secure is this message? And there's a reason why we don't still use Caesar Cipher. And the reason is because it's not actually the most secure thing out there. And the reason for that in general is because if I know that there's a Caesar Cipher, right? That you're using a Caesar Cipher. There's really only 26 possible things that message could mean. So we have this jumbled, right? It looks like gibberish, but if I know that you're using a Caesar Cipher, or really any single substitution cipher where you substitute one letter with another in a very uniform way, it's actually relatively easy to crack. And now we're going to actually crack this. So let's first create a message that we're going to pretend we don't know, right? So like our message would be, we're going to encrypt the message. This is a super duper secret message. Okay. So now let's say I'm a bad guy, right? And I don't know what this message is. I just see this, but I know you're using Caesar Cipher, right? So I know that because I know that you're using a very old computer or a calculator or something. But anyway, you're using Caesar Cipher, using this very old method, and I know it. How could I decrypt this without knowing the key? Because if I know the key, right, like I would. Which, when I say key, I mean the shift, right? So if I know this, I could just decrypt it with 23 as the right shift, right? But let's say it wasn't this, right? And it was like 5, right? And I tried to use 23, I would get gibberish, right? So how could I figure out whether that's, how to decrypt your message? Because another important thing about this is generally, if you're sending messages with one specific type of encryption key in a way like this, other messages are probably also going to be sent with that same type of encryption. So if I can decrypt one message, I can decrypt them all. And there's actually quite a few interesting documentaries about World War II with regards to this, where, this became a really big part of warfare, actually, was trying to understand how to read other people's messages and whether we should make it clear whether we can or cannot read those messages, because then they could change the encryption key and it would change the entire message. In any case, let's talk about how we could decrypt this very simple message. The way that we could do it is really just literally go through every single possible value, because there's only 26 of them, right? This is called brute force, where we're going to just try every possible, knowing that it's a Caesar Cipher gives a lot of information, and we're just going to try every Caesar Cipher with every right shift number until we get something that looks like text. And how we do this is using the old trusty for loop that we've been using so far. So we're going to say for, okay, and then right shift in range 26. So this is going to be 0, 1, 2, 3, all the way up to 25, which is going to be every single possible iteration. And that's all of the possible right shifts. If we increase this number, it would still work, but you'd end up getting repeats. It would go in a cycle, right? So, you would just end up repeating yourself over and over and over again. So we're just going to do this, and we're going to print out decrypt message, and we're going to use right shift, right? And we're also going to print out the right shift, meaning what the right shift we're using. And we're going to just format this a little bit nicely. So we're going to say right shift is this. Decrypted message is this. And we're just going to look at it. And I'm going to print out a little bit of a nice separator like we did last time. And we're going to take a look at this. Now, if we look through these values, right, we're going to see a bunch of jarbled up text, right, for a bunch of different keys. And you can just, by eyeing it, you should eventually find the correct key. And it's right here, right? Right shift 5. This is a super duper secret message. And this was the original message that we had sent out. So I was able to crack my Caesar Cipher, which is why you probably don't want to use a Caesar Cipher, right? I could use any number here. And if I look through it, use the same method, I will be able to find one that looks like regular text. This is a super duper, so for 17, this is a super duper secret message. So anyway, I know what that number is, but even if I didn't, I could just test this and eventually I'd find the right one, right? So it's very easy to crack. And just like a hacker, we were able to crack this very, very quickly, right? There's only 26 possible things we had to check through, which in terms of cracking something, that's a very, very small number. Okay, so that's if we know it's a Caesar Cipher. Now, what if we didn't know it was a Caesar Cipher? Then it would get a little bit harder, but it's not nearly even close to impossible. The first step would be trying to determine that it is a Caesar Cipher. If you can look at frequencies of certain letters and you see that it comes up in a similar way to the regular alphabet, the English alphabet, then you'll be able to quickly determine that it's a Caesar Cipher. And then once you know it's a Caesar Cipher, you could just apply this method. So the first idea is, figure out if it's a Caesar Cipher first. If it is, then just apply this method because there's only 26 possible, which is surprisingly easy to do if you're trying to crack something, right? So the first step would be trying to figure out that this is a Caesar Cipher. I would look at the frequencies of these letters and see if it follows a similar pattern to the alphabet. If it does, I can guess it's a Caesar Cipher and just try this out, right? So there's very little cost to trying it out. And what I just mentioned is another way. You can look through the values and look and see if there's an actual readable message there, right? That's kind of the best way to do it. Or if you have some kind of repository of words in a language, like English language, you could just keep searching through things until you find the sentence that has the most number of words in it, right? Which is probably just going to be the correct message. But words could come up by accident. It's possible, right? Not too likely, but especially small words like is or a could come up. So, but anyway, that's the idea here. So if we don't know it's a Caesar Cipher, we could try to figure it out by looking at the frequencies. Now, we're not going to do too much of that now because that involves a little bit more expertise than we know. This does get us a lot of the way towards cracking Caesar Cipher, but because it is so easy to crack, Caesar Cipher is considered to be equivalent to no encryption at all by modern security standards. So definitely don't use Caesar Cipher to actually encrypt any messages. But now you've been able to crack it if anyone else does using programming. So congratulations. You can now consider yourself a hacker.